That's what my mom says. My mom will be like, "What's wrong?" And I'll be like, "Oh, nothing." Really, I'm pissed off at the world.
Oh, no, I'm not though. I would tell you if I was. Okay, so here we go. I want to go through a couple examples. Now, I'm going to be mad if you don't listen, but oh, that's much better. Now I'm happy. Okay, so here's the problem. You're asked to do a problem like this on the homework, and I'm thinking maybe I'll do one of these on the test too. It's such a good problem. Okay, we're told that we've got these two functions, blue and red, and we even get the equations for both of those. We're told that they intersect once at x equals 1. Okay, and we can even see that intersection on the graph right there. Yeah, in fact, they intersect more than that. But we're given that one of these occurs at the point 1 something. Okay, so one intersection is at x equals 1. Our job is to find the coordinates of all of the points of intersection. Okay? Well, we could find the coordinate of that one pretty easily. How would we find the y-coordinate of this point of intersection? How'd you get that? Okay, but what if it's actually negative 2.997431? Say it again. We'll put in 1 for the x's, yeah. Okay. Which function should I plug that into?
Your blue one.
Okay. Or doesn't matter. Amanda, how come? Because they're both crossing at the same value. Exactly. Very good. Okay, everybody with me? So yes, she's on a roll. Okay, so we might as well pick the easiest one. If I put 1 back into the red function, that's pretty easy. Negative 1 squared is just negative 1. Minus 4 is negative 5, plus 2 is negative 3. So we got one of the three. Good. We got to find the others, though. Okay, in order to find the other points, we first need to find the other x-coordinates. Now, how are we going to do that? How are we going to find out the places where these two functions intersect? Any ideas?
Can you repeat the question?
Yeah. How do we want to find the places, meaning the x values, where the red and the blue functions intersect? Well, okay, but without the calculator.
One seems to be.
Okay, I don't want seems to be, and you're probably right, because this is convenient, but what if it wasn't convenient? Okay, now I'm going to give you a little bit of background info, and I'm going to ask you again. Okay, how about this now? Let's remind ourselves what it means to be a point on a curve, to be a solution of an equation. Now, if I want to pick a solution of the blue equation, there are two variables there. So when I say a solution, I mean values of x and y that work, that satisfy the equation, right? If I pick, for example, an x value of 0, there's only one y value that goes with that x value. If I put 0 in for x, I get 0 plus 0 minus 0 is 0, right? So the y value on the blue curve that goes with x equals 0 is y equals 0, and we can see that because there's the point at 0, 0, right? Now, for every value of x that I pick on the blue function, there is going to be a one value of y that's going to work. Infinite number of possibilities. If I were to string together an infinite number of blue beads that I'm going to glue together on this piece of wire or something to make this shape, let's say, each one of those beads corresponds to an ordered pair on the plane. For every possible value of x, I could calculate a y value, and those would represent the location of a blue bead, right? If I put them all together, all infinity of them, I get this blue shape. Same thing for the red beads on the red curve. For every x value that I choose, I get a y value. Each one of those ordered pairs corresponds to a location of a bead. Now, how many of those beads, the blue beads and the red beads, are at the same place? Looks like 3. There's one there, there's one there, and there's one there. So now I ask you again, if I want to find the places where the y values are the same, right? How could I find those? not subtract. If I want to know where is this function calculating the same y value as this function is.
Multiply by, then long division. You should have all.
What can I do?
You should have.
I'll say it again. I want to know when is the blue expression. Now, just think. Now, listen and think while I'm saying this. Just think real hard. When is that blue expression right there, x cubed plus x squared minus 5x? When is that calculating the same values as this expression? Well, I don't know. You can't give me an answer immediately. How can I find an answer? When they're equal to each other. Exactly. That's it, right? If I want to know where the y values are the same, I'm just going to set this expression equal to that expression and solve. And the math gods in their infinite wisdom will tell me through algebra all the places where that happens, right? No.
I was going to ask you, like, well,
So we're going to set x cubed plus x squared minus 5x equal to negative x squared minus 4x plus 2, right? Now, how many unknowns are there in that equation? How many different variables?
3, 5.
1.
Oh, 1.
Wait,
What is it?
Oh, X.
X.
Yeah, I was counting all the X's.
Okay. No, I don't care about the instances of x. I want to know how many different variables are there. There's only one. Now, in algebra, and you can take this to the bank. This is what will always work in algebra. I only need as many equations as I have unknowns to solve for that unknown. Sometimes it can be harder than others, but if I have one unknown, I only need a single equation with that one unknown in it. Now, if I had two unknowns, I got to have two separate equations, but I only have one. So I should be able to then, by using my algebra skills, I should be able to somehow find out the values of x that work in this. Okay. Now, how am I going to do it? Now we shift into, we've gone from kind of the story problem type thing. We had a problem to solve. We're able to translate that into an algebra equation. And now we can just kind of put on the blinders and shift into algebra mode and just do the algebra.
I love algebra.
So, well, you know, algebra is not probably the most fun thing in its own right. But algebra is like, let me think of it this way. Algebra is like learning fundamental skills in a sport. Or it's like being able to, it's like letters for
It's
writing.
something that you'll actually use in life.
Algebra is how, anything you want to do with math that's at all complicated has to be done through the vehicle of algebra. So it's the most commonly used skill in math because it's how you do abstract stuff. So now we're gonna put into practice this algebra stuff that we've been learning for a long time and practicing. And in chapter 6, we're dealing with solving polynomial equations, which is what this is, right? I got a bunch of powers of x just added up. So how would I solve this polynomial equation? What's the first thing I got to do here?
Add up like variables.
Okay, good. Another way of saying that,
It's on one side.
get all the x's on one side. Good. Push everything probably to the left, because I've got a positive x cubed on the left already, right? So I'm going to add x squared to both sides.
Hey, I have a quick question.
Yeah.
Would you consider Mr. West an astronaut?
Mr. West?
Like
Yeah.
Zeus.
Absolutely.
Is he actually Zeus as an astronaut?
Absolutely. Okay, so if I add these up, I get what? X cubed, x squared plus x squared, 2x squared, negative 5x plus 4x minus x, and then minus 2, and then over here everything cancels. Right? So there is my polynomial equation in standard form. Okay, that's what we got to solve. Now, how do we do that? Well, it would be, we actually could do this one. Anybody have a suggestion how we could solve that given nothing else? Factoring by grouping. Wouldn't work here. But we're given something better than that. We're told that x equals 1 is a solution. We're given one solution already, right? So then we know that our goal in solving this thing is to, let me rewrite it a little bigger. So here's where we're going with this. We've got x cubed plus 2x squared minus x. Our goal, if we want to solve this polynomial equation, is to break it up into small enough pieces that we can set the pieces equal to 0 and solve those smaller equations, right? Well, we know one of the pieces. If x equals 1 is a solution, what is the factor that goes with that? Now, normally, I would have broken this thing up into factors first. This factor over here, the solution is x equals 1. What's the factor if I turn around my normal thinking?
X minus 1.
Yeah, x minus 1, right? X minus 1 is what I would have said equal to 0 to solve and get the answer x equals 1. The formula is simple. If I want to find the factor, I just subtract the 0 from x always, right? So there's one of the factors. What we want to do is just find that guy. If I knew what that factor was, I could set this one equal to 0 and solve, right? Okay? So how do we do that? Well, how do we do that? If I know that x minus 1 is a factor of x cubed plus 2x squared minus x minus 2, how do I find the other factor? Think of it in terms of numbers. If I did this in terms of numbers, it's really simple. What if I had 2x equals 6, and I want to know what x is? What do? Divide by 2. Same thing here, right? If I know that this times this, green times blue equals black, then blue must equal black divided by green, right? Right?
Now we're speaking green.
Okay, all right. So we should be able to just divide this thing out then, right? If I want to solve for this,
How'd you get 6?
I just made that up.
By the colors.
Oh.
That was just my example with numbers.
Oh. No, seriously.
Okay, so we're just solving for a. That's the other factor. Divide both sides by x minus 1. Now, what's the easiest way to divide this big polynomial by x minus 1? Well, no, but to divide it. Synthetic, because I have a linear factor on the bottom. Okay, so... Oh, shoot.
You shouldn't swear on the board.
No, it's true.
Do you delete comments and like send them hot?
On the recordings?
Yeah.
No. I don't have time for that. Are you kidding me? So if I divide this out synthetically, what are the coefficients?
2,
1,
2, 2.
and the 0 I'm putting out front? 1,
1.
right? 1 was a solution. So then what goes in here? If x minus 1 is a factor, or 1 is a 0, what's the remainder have to be?
0.
0. Okay.
I didn't actually get that.
So now I bring this down, right? And that becomes a 1. 1 times 1 is 1 plus 2. 1 times 3 is 3 plus negative 1. 1 times 2 is 2, and sure enough, they add to 0. Okay, so then that tells me that A, right up here, right, which is what I get when I divide these things out, is what? What does that mean? Yeah, what's that mean? Okay. Constant coefficient of x, coefficient of x squared, right? And then I'm just adding all those terms up, right? So that's my answer. That's what A is. Right? Right?
Gotcha.
Okay? All right.
That actually kind of seems simple.
Yeah, it's not so bad.
X minus 1 again?
How did I say it again?
How'd get x minus 1?
Because that was given to me. Remember, that was the.
Oh, one of the intersections.
Yep. Okay. Okay. All right. Okay, last one. What about this guy?
He's getting his teeth cleaned.
What about this guy? Okay, let's say we know this time. Okay, what about that? There's the volume function. Okay, we're told that we've got this rectangular prism, and here are the dimensions. We know that the length of this thing is x plus 5, the width is x plus 1, and the height is unknown. We want to find the missing dimension. Okay, so how do I calculate the volume of a rectangular prism?
Don't you have to do
Length times width times height, right? Okay, so then I should be able to take the product of those three dimensions. So I get x plus 5 times x plus 1 times whatever we want to call the missing one, just call it a, equals 3x cubed plus 8x squared minus 45x minus 50. Okay, now what would I do to solve for a, the missing dimension here? This is just algebra. Okay, got to divide. Divide by what? Okay, divide by the blue stuff. Right. Everybody see that? Now I've got two options here. I want you to think about these and tell me what you think is going to be the easiest way to do this problem. I could FOIL those out and get a single factor and divide once, but Cody's shaking his head. How come?
That doesn't sound easy at all.
Okay, it doesn't sound easy. Now the alternative is, that means I would only divide once. Or I could divide through both sides first by x plus 5, get rid of that, get an answer, and then divide that by x plus 1.
Yeah, so I do.
I would too. Even though I'm dividing twice, how come that one's so much easier? Okay, and good. And I'm dividing by linear factors, so what can I use? Synthetic division, which is way easier, right? So let's zip through that real quick. See what we get. Okay, so if I'm going to divide by x plus 5, what are my coefficients?
Don't you have to do it with
Good luck
one?
hitting baseballs.
What's that?
Wouldn't you have to do it with one?
Yeah, we do with both of them. Right. So now, what are the numbers I put out front? What's the 0? If I'm going to divide by x plus 5, I put a negative 5. And then what needs to go in the remainder box? 0. Okay, and what do we get if we do that? Let's see. 3.
Negative 28. Negative 28.
35. Okay, and those cancel. Okay, done. Right? What did we get when we divided that? Well, we got this. 3x squared minus 7x minus 10, right? But now we got to divide that by x plus 1. So let's just go again. Right? We'll just nest the division. What goes out front this time? Negative 1. Okay, and what do we get? Okay, so then now we got it. We got the A by itself. What is A equal to?
0.
What's that? 3x minus 10. That's it.
That's
That's
just really time consuming, but it's kind of.
what's that?
Isn't that supposed to be a negative 3?
Right here.
No, down. No, down.
No, the 3x. Which is the negative 3x?
But
No,
I thought you did because you did negative 1 times 3.
no, I bring this straight down first.
Oh.
Remember?
Oh, okay.
Yeah. So A is 3x minus 10. So if I go back up here, I know that's the missing dimension. How about that? Okay, make sense? All right. Hey, that was quick. Forgot that. We actually have time. That was, yeah.